Hello and welcome to this relatively short introductory video on HVAC Economizer and Power Exhaust, part of our beginning level series of videos at MEP-Precon.com. This is designed for the newcomer into the HVAC industry, and we're going to talk to you about what Economizer and Power Exhaust, because it's kind of related to that, what they are, when they're used, to get you up to speed quickly within our industry, to be more valuable to your employer and to your customers. All right, the objective of this is to understand what an economizer is, if you've never heard of that before, when it should be used. There's a couple different types of economizer. We'll talk about that and distinguish the differences there. And then we'll talk about the difference between barometric relief and then powered exhaust, and know when and how to use powered exhaust. Those couple of terms, they're power exhaust or powered exhaust and economizer. You're going to hear a lot in the HVAC world, and so this is to help you understand what those are and when they're used. All right, so economizer. What if you've never heard of that before? What do you suppose an economizer is, just by the name of it? Something, if you're going to economize something, what does that mean? Well, I think, yeah, you're probably on the right track, that it's meant to, you're going to save money by doing something. You're going to economize it. You're going to reduce the amount of money that you spend by using this device. So an economizer is the ability for an HVAC system to provide cooling to the interior space when the outdoor conditions, the ambient air outside, is in a state that you can do so. So people sometimes think of it or talk about it as free cooling, because you're using the outside air to cool the space versus an expensive compressor and a refrigeration cycle. And if you think about this, if you have an air conditioner in your home, you do this all the time. When springtime arrives, as it's getting warmer, in April or May, depending on where you live, it starts to get kind of warm, and to cool off the house, what's the first thing that you do? You probably don't go immediately and turn the thermostat on to air conditioning. If it's cool outside, especially in the mornings, you open up the door, don't you? You might open up the back door and the front door to get a little breeze in, because you know intuitively that if it's cooler outside, that's just going to cool the space down a lot more economically than running an expensive air conditioning unit. In addition to providing some fresh air in the spring, if your house has been sealed up and closed off for most of the winter that way. And so it saves money by allowing that outside air to help cool your space, flushing out all the heat, as opposed to running an expensive compressor on an air conditioning system. It brings in all outside air. So normally with an air conditioning system, you have a lot of return air. You save some of that conditioned air and it just recirculates back and gets conditioned again. But with an economizer mode, you're bringing in all outside air. And so we have to relieve that air somehow. We'll talk about that here in a minute. So a couple different types of economizer. There's an economizer that's based on temperature. And then there's an economizer based on enthalpy. Ooh, enthalpy might be a new word for you. So enthalpy is essentially a property of the air that you would find on a psychrometric chart. This chart that you see here is a psychrometric chart that HVAC engineers use, and describes a lot of different processes that air might be going through, as far as dehumidifying and humidifying. But essentially what enthalpy is the amount of energy in the air, and it's a combination of temperature and moisture. So you could have low temperature and high moisture, or the opposite, and it could be around the same enthalpy. And so the significance of that is, if you just had an economizer set for, okay, if once it gets to be, say, 55 degrees outside, we're going to bring in outside air. Well, you may not want to do that if it's raining out and if it's, 98% humidity or something, just because that's going to make your indoor environment really humid, and then eventually you're going to have to run your air conditioner to wring out all that moisture, and that's going to be expensive. So you may want to lock out the economizer if it's really humid and moist out. So that would be an enthalpy type of economizer that senses the total energy, not just the temperature, but also the humidity, and to test to see if it's in a state that, yep, we can use it to bring in, just that 100% fresh air and use it to cool the space without causing any harm to the interior from an over humidification standpoint. Like I said, it's 100% outside air, and so we're going to have to relieve that air somehow. And that's best accomplished with louvers or a hood. Now, if you remember in that first slide, that picture of that packaged unit, every little packaged air handling unit has two openings to the outside. One is to bring in outside air, and then it also has an opening to relieve the air. But sometimes you could have some recirculation between that relief air and the outside air that you're bringing in. So it's always better if you can separate your outside air and relief air and have that relief air, be further away. The trouble is it's a little bit more expensive. You have some expensive either roof vents or some louvers to relieve that. But it works better if you can separate that way, separate the two streams of air that way. All right, so if you're bringing in a bunch of outside air, you have to relieve it somehow, and especially in economizer mode, when you're bringing in 100% outside air. You see in normal mode, normal occupied mode, outside of economizer, you bring in some minimal amount of outside air, just enough that it meets the code requirements for the number of occupants that are in the space and to prevent it from getting too stuffy and so forth. So that might be, I don't know, somewhere around 20% of your total supply air that's being supplied to your space. But an economizer, 100% of that air that's being supplied by that fan from the unit is outside air. And so as you can imagine, it's going to build up pressure in your building, quite a bit of pressure, unless you can relieve it somehow. Probably not so much pressure that's going to burst your building like this picture shows, but we do need to accommodate it somehow. We need to accommodate it with some exhaust or some kind of relief. And so that's where powered exhaust might come into play here. Okay, so let's take a look at a schematic of a typical packaged unit that has, like in that first picture that you saw, a packaged unit. Here's our outside air that comes in. It's got a little hood, and it usually has some kind of a filter. And there's some dampers. Maybe there's another filter here, and here's our supply fan, and then it goes down to our space, and then the return air comes back. And then there's a coil in here too, and there's a compressor and a condenser, and all the components of the refrigeration cycle would be in here if it's a packaged air handling unit. But anyway, let's just look at the outside air and the exhaust air streams here. So the outside air comes in and it mixes with the return air. Now, a packaged AC unit does a pretty good job of trying to relieve the amount of air that comes in. It relieves it just kind of by the geometry of how it's made. It's meant to come through here, and it just gets relieved through normally just a barometric type system. There's a barometric damper, which means it opens up just based on the pressure behind it. But the trouble is, and where you would need a power exhaust, so this schematic here actually has a power exhaust fan. So when you need that is when you have a lot of resistance in your return duct here. So if you have a ducted return system as opposed to a plenum return system, which is common in a lot of office spaces where you just have grills, return grills in the ceiling, and the return air kind of finds its way back to the big air handling unit here. But if you have a ducted system, you have a lot of resistance, and it's a pretty tall order for that return air to come back here, either to come back to the supply fan or to be, especially to be exhausted out that way. So what air does come back here, it's going to want to take the path of least resistance, and it's going to see, oh, here's a negative pressure here by this fan. If there's no fan over here, it's going to just all going to want to recirculate with that supply fan and go back down the supply air duct, and you're not going to get any relief that way. And so if you don't have any relief anywhere else in the building, like those hoods that you saw or louvers, it's just going to build up pressure in the space, and doors are going to kind of stay cracked open, and you're going to hear whistling, and it's going to be a very uncomfortable and undesirable situation. So we have a power exhaust fan. We would put a powered exhaust fan onto our unit, and you could also do this if it's separated too with louvers or something. But typically when we talk about a powered exhaust fan, we're referring to an accessory within a packaged AC unit, and it's meant to help pull that air through that long stretch of return duct where there's a lot of resistance and mechanically exhaust that out, not just barometric relief, but mechanically pull it out so that the building doesn't overpressurize. We can pull out some relief air, and then by pulling it out, it makes it a little bit easier to bring in outside air that way too. It keeps the whole building balanced. So that's it. That is Economizer. Economizer is 100% outside air when the outside air conditions are such that you can use it for free cooling for the inside. And then a power exhaust is what you would use if you had a lot of resistance in your return duct that way, to make sure that we're positively exhausting all that air and not building up pressure. That is all there is. I hope you understood that. If you'd like to incorporate this at a larger scale, contact us at MEP-Precon.com and we can talk about that. If you found this video directly on YouTube, please jump over to the website and find that assessment. Make sure to take that assessment and score 100% on it. You want to make sure that you retain this information and that you learned it. If there's anything in there, a couple questions that you didn't get right, come back here and just fast forward the slider to that section, or look at other resources on the internet too. But really important that you understand this concept of economizer and power exhaust, because it's used a lot in our industry, and it's really important to make sure to have a comfortable building. Check back here often at this YouTube channel, and we'll always be adding some more videos to help you out in your pre-construction activities to get you more technically educated. All right, thank you.